Okay, so for today, like I said, we're going to be working on the pre-lab stuff, and it's going to be pretty straightforward. It's just important that you pay close attention because essentially this format is what's going to be used for all of the labs you're going to do in this course. All right, so first thing, it's in Google Classroom. It's in the stream as well as in the class work tab under assignments. You'll see Properties of Compounds lab. If you click on that, you will see several things. Okay, the first one is a PDF document. That's the lab sheet. It's what I'm going to be working from today. Okay, and you guys also can look at it if you want, but for today, don't need too much from it. Okay, there's also a Properties of Compound observations video. You guys aren't going to need that because you're going to be doing this lab tomorrow, getting the observations yourself. Okay, but in case you're absent, that allows you to get the observations you need for the lab. You just have to watch me do the lab. Okay. Also, if you are not confident in any of your observations in the lab tomorrow, you can always double check them. Okay. And then there's this video here, which is going to be what I'm doing for you right now, which is going through all of the pre-lab stuff. So when you're putting your lab report together and you think it's pretty much done, you can always kind of review that again and see if you did all the little things I said to, or if you got all the hints that I dropped, all of that kind of stuff. Okay. And then this last video here is actually for the analysis and conclusion, which we'll do on Wednesday. Okay, and we'll go through that. And then the final thing here is your Google Doc. All right, so you will need to open that up. Okay, it is yours to edit. It is unique to you, which is why it has your name on it. Okay, this is the document you're going to be submitting for grading. Right, so as I go through all the stuff today, you want to be typing in here and filling it all in. All right, because as I showed you yesterday, every time we do a lab, you're going to get the template. Okay, this is the template. All right, so it has blanks that essentially need to be filled in. It has the materials here for you already. Okay, it's got a chart for your observations to be recorded in. So you can either, for tomorrow, print this and write in it tomorrow, or you can just type them in on your phone in the lab. Either one. Okay, and then you have your analysis. Okay, you'll be filling that in. Okay, so was substance A ionic or molecular, and what was it? And then you'll have your conclusion and evaluation after that. Okay, so for today, we're mostly going to be working on problem design, hypothesis, and procedure. All right, you and your group will come up with the procedure and steps and instructions for yourselves to follow tomorrow. Okay, questions so far? All right. So the premise of this lab, okay, is that we want to be able to identify unknown compounds based only on their physical properties. Okay, so our problem, which of course you have to put in your own words, has to say something like that. Okay, like what I have written there is how can several unknown samples be classified as ionic, molecular acids or bases in order to find their identity? Okay, you have to say something along those lines in your own words in the form of a question. Okay, a problem is always a question. Okay, so how can unknown substances be identified with physical properties or whatever? Okay, you just have to put it in your own words in the form of a question. I don't hear a lot of typing. I gave you a pretty big hint there. I would suggest putting stuff in this document as we go along, guys, because if you try and remember what I said, you're going to forget it later. Okay? So for the problem, something like this about how you're going to identify unknown samples with their physical properties. Okay, you got to put that in your own words in the form of a question. Okay, for the design, we already know that the lab is going to work kind of like this. You're going to have a bunch of unknown compounds at the front of the lab. You know that you are going to be running 4 sets of tests on all of them. A physical or an observable properties test, a solubility test, a conductivity test, and a pH test. Okay, you know that those are the 4 things you're going to do. Right, for every single one of those samples. right? And then we're going to collect the observations, okay, of whether they're soluble, whether they conduct electricity, whether they're blue or green or white, okay, all that stuff. We're going to get a set of data for each unknown compound. And then from there, we're going to use those properties to identify them. Okay, so we're performing the same 4 tests 12 times in this lab, okay, on 12 different unknown compounds. So in this experiment, what is my manipulated variable? What is different? What am I changing each time?
The compounds.
Exactly. Okay, in this lab, the compounds, the unknown compounds, are our manipulated variable. Now remember that your job here is to explain how and why they're being manipulated. Okay, we've identified that the unknown compounds are in fact our manipulated variable, so you kind of got a freebie there. Okay, you need to explain to me how and why they're being manipulated. So let me give you a little hint for that. Okay, in this lab, we are trying to find the identities of 12 unknown compounds that each have their own set of unique physical properties. Okay, we're going to test them all the same way. Find those physical properties and use them to identify. Okay, so I've just said how and why in 2 different ways. Okay, but obviously I don't want you to write down what I said. I want you to paraphrase, make it sound like yours. Okay? So how are we manipulating them? Okay, kind of testing a different one each time. Okay, why are we manipulating them? Okay. Because we want to identify them based on just their physical properties, which are unique to them. Okay, the responding variable in any experiment is the thing that changes as a result of the manipulated variable. So each time I run the series of tests, I'm running it on a different unknown compound. What's going to be different each time I do that?
The results.
Okay, and what are the results?
Whatever answers you get for each of the different tests you do.
Mm-hmm. I'm thinking of 2 words that both start with P. When I run the tests, I'm trying to find the what?
Product.
Close.
Properties.
What kind? Also
Physical
starts with P?
properties.
Physical properties. Okay? The responding variable here, it's another freebie. Okay? The responding variable here is the physical properties of each unknown compound. Okay, now here's the hint for the how and the why. Every time I run these tests, each unknown is going to give me a different set of results. Okay? So every time I run the tests, I'll get a different set of data because each one has its own set of unique physical properties. Okay. In this lab, we have to identify 3 controlled variables. So there are way more than 3 things, but there are 3 things, we got to identify and explain 3 things that need to stay the same each time we run the tests in order to have a fair comparison. Okay, so every time I test a new compound, I'm testing it in the same way. I'm running the same 4 tests on each unknown compound. Okay, are there some things that I should keep the same each time I do individual tests? Okay, like I'm thinking some things might be procedural, that would be how I do them, and other things might be environmental. So that would have to do with the conditions under which I'm doing the tests. Because some of our tests might be affected by environmental conditions. I'm thinking specifically the solubility test is greatly affected by one specific environmental condition that is going to stay the same throughout the whole lab, because it's controlled by that thing on the wall. Notice I'm not giving these ones away. I gave you 2 freebies. Okay? You guys got to come up, okay, with 3 things that are going to be the same every time for each unknown compound. What are 3 things, either procedural or environmental, that are going to stay the same throughout the lab? Because if they didn't, they could affect the results. Okay? Another thing I'm thinking of here is, yesterday I kind of specified when I showed you the depression plate, I said, you know, you could cover the depression plate, just cover the bottom. Okay? So every time you put something in there, you just cover the bottom. Do it the same for every single one. Okay? Could be something that could affect some of your results. Okay? Remember, you need a how and a why here, right? Okay, just to kind of help you out, because I'm seeing a few like really panicked, confused looks here. So one of the controlled variables has to do with that thing on the wall. What does that thing on the wall control? Temperature. Okay, temperature is a controlled variable. How is it being controlled? By the thermostat. Okay, it's going to make sure that the temperature in the room stays the same. Why? Why is it important that the temperature stays the same? What could it affect?
Solubility.
It could affect the solubility of the substances. Okay? If the temperature changes radically between substance A and substance J, I'm going to get a lot more substance J to dissolve because my water will be that much hotter. Okay? Things like that. Right? That sort of makes sense? So you got to come up with 2 more. And I kind of half gave you the second one. Okay? You got to come up with a 3rd. How are you controlling it? Why are you controlling it? Okay, so the premise behind this lab is that every compound has unique physical properties. That's the premise that we're working on. Okay? If that's true, and we run some tests on these unknown compounds, then each compound should give us what? Should I get different results for each one? Could those results help me identify them? I think some of you have figured out where that goes. Okay. Notice that in that last statement I made, I used 3 specific words. If, and, then, which are part of what? Right? Okay. Remember that in a hypothesis, the if part is the premise that we are working on. Okay? The premise in this lab is that everything has unique physical properties. Okay? The and part briefly describes the experiment. In this experiment, tests are being run to identify physical properties. And we're hoping that those physical properties will allow us to identify the unknown compounds because each one will have different results. That's the idea that we're working on. Okay? You need a hypothesis, if, and then. It kind of says that in your own words. It's going to be kind of a long sentence. Your English teacher might tell you it's a run-on sentence. I don't care. This is science. We live by our own rules. Okay, so the next thing in that document that you're working in is the list of materials. Okay, so you don't have to come up with the materials, they're already there. Okay, but among that list of materials are the identities of the unknown compounds. Okay, tomorrow you're just going to see A through J, but up here are the possible names that go with A through J. Right, so one of the possible compounds that we're dealing with is ammonium nitrate. Okay? Now, ammonium nitrate, okay, is actually, and this might be important for you, the compound that's used in instant cold packs. So if you've ever used one of those ones where you pop the little water bubble in the middle and then you shake it up and it gets cold, that's the powdery stuff that's in there, the crystal stuff that's in there, is ammonium nitrate. Okay? When it dissolves in water, it gets colder. That might be important tomorrow. Okay. I also want you to look at what its formula is, NH4NO3. Think about what kind of compound that might be. It is going to be solid. Okay. The little S means that it's in solid form when you get it. Okay. Another one of the possible identities is copper 2 sulfate. So one of the compounds is copper 2 sulfate. We learned a couple of things about copper compounds yesterday. Okay. Another one of them is ethanol. Okay. That's alcohol. It's the stuff that's in hand sanitizer. Okay. And hand sanitizer has some pretty distinctive physical properties that you are, well, due to COVID, much more familiar with. Okay, than maybe previous groups of Science 10 students would be. Okay. I'd also want you to look at that and think about what kind of compound it might be, ionic or molecular, because that might help you with some of its physical properties. So the idea here, guys, is today, not only are you and your group going to come up with your procedure, but you might want to brainstorm what you think some of the possible physical properties of these unknown compounds might be. So that tomorrow, when you're running the test, you can go, you know what, I'll bet that's this one. Okay, I'll bet F is this one. Okay, because that one's supposed to be green. Okay, or that one's supposed to be, you know, blue or whatever. Okay. Paraffin. Okay, paraffin is what candles are made out of. Okay, candle wax is paraffin. Right, and it's C25H52. So think about what kind of compound it is. Think about what candle wax is like. Okay? Obviously, I'm not just going to have a candle in a beaker. Okay? I've done something to mask its appearance. Okay, a little bit in the lab, so it's not, you know, oh, there's a candle. I wonder which one that is. It's not going to be that obvious. Okay. And then we also have sodium chloride. Okay. Well, we know that sodium chloride is an ionic compound. Okay? We know what it looks like. We use salt all the time. Okay? Think about what its physical properties might be. Sodium hydroxide, okay? NaOH, okay? Also an ionic compound. Okay? It's got a metal and a polyatomic ion. And that polyatomic ion is probably going to cause this to have a certain property that will help to identify it. Okay? As it ends in OH and is ionic. Okay? Then we have hydrogen chloride. Okay, and hydrogen chloride is an ionic compound as well. Hydrogen's acting as the metal. And there's certain properties for ionic compounds where hydrogen acts as a metal. Okay, we got sucrose. It's table sugar. Okay, C12H22O11. Okay, you know what that looks like. You know what kind of compound it is, what its properties might be. Water is one of the unknowns. Okay, well, in basically every test we run, water is going to come up negative. okay? I mean, it's, you know, a clear liquid with no odor, okay? And when I try and dissolve it in water, it will probably dissolve just fine. Typically when you pour water into water, they mix together, okay? What's its pH gonna be? Yeah, 7, right? Okay. Will it conduct electricity? No, distilled water won't, it's a molecular compound. Okay, that's the brainstorming that you and your group have to do, okay? I only do water because obviously water is obvious, okay? For the other ones, you guys need to kind of come up with what do you think those properties will be so that you can be ready for tomorrow. Okay, cobalt 2 chloride, okay, another one, okay, we got another ionic compound there. Nickel 2 chloride, another ionic compound there, okay. And then we talked about the other apparatus, the other pieces of equipment. You'll have the wash bottle full of distilled water, okay. You'll have a scupula, okay. Scupulas come in a variety of different forms, but they are all a scoop and a spatula. Scupula, okay, so. Some of them look like this, some of them have a big fat handle on them with kind of a half of a tube so you can scoop and scrape. Okay, again, scupula, it's half scoop, half spatula. Okay, so there will be one of these in each one of the unknown compounds. Now, is it important to make sure that you put the same scupula back where you got it? It's really important. You don't want to take the scupula from A and put it in D, because then you'll contaminate D with A, and that can interfere with everybody else's results. Okay? So you got to make sure that it gets back in there. If you forget, and it happens, just tell me. I'm not going to make fun of you out loud. I will in my head, but I won't make fun of you out loud. Okay? And I'll just rinse it off and make sure that it's good to go back in, and I'll figure out whichever one it came from. Okay? Once it's clean, it doesn't really matter. Okay, so if you forget, just tell me and I'll clean it and it'll be fine. Don't just go, I think it was that one. Okay, that's gonna end badly. Okay. Some of these, tomorrow, are going to be liquids. Okay, obviously we don't dispense a liquid with one of these. Okay, so they'll have eyedroppers in them. Right, so you'll just squeeze the bulb of the eyedropper and squeeze it into your depression plate. Okay. All right, and you know the other ones because I showed you the conductivity apparatus, the thermometer, and the pH strips yesterday. That was the only thing I didn't have with me. So we're going to be running 4 tests. We need to make sure that we are specific in our instructions for how to perform those tests. Here's what I mean by specific. When you're telling people to perform the observable properties test, tell them how much to put in and what things to observe and how to observe them. Be specific. Okay, when you're saying, you know, detect the odor of the substance, don't just say detect the odor, right? Somebody might put their face right in the beaker. Right? Make sure you tell them you want to just waft that material, okay, and look for a smell. Okay? When you're telling them what other observations to make, tell them record important properties like color, okay, or texture, or state, or whatever. Tell them how to do that. Okay? What does texture mean? Is it crystalline? Is it soft? Okay? Things like that. Does everyone kind of understand what I'm saying? You want it to be specific. 5 marks out of 30 are on your procedure, and if it's not specific, you're going to lose marks. Okay? Because I've had people, they hand in this lab report and they're like, step 1, get stuff. Step 2, record physical properties. Step 3, add water. Step 4, check conductivity. Well, how do I check the conductivity? Do I take a car battery and some booster cables and go like this? Okay, like be specific. Tell me what to use. Tell me how to do it. Tell me what to record. Okay, record the number that it reads on the face. Okay, when I'm doing the pH test, don't just say do pH test. I don't know how to do that. Okay, take the pH paper, place it in the solution, compare it to the colors. Okay, record the number that corresponds to the color. Okay, stuff like that. Be very, very specific. You have all of the rest of class, which is a significant amount of time, an hour, okay, to do so. Okay, sorry, not quite an hour, but you got lots of time to do this, half an hour, sorry. Okay, everyone follow me there? Yep. Okay, so be really, really specific. And to start this off, you need to go in and put what on right away? Safety goggles. That's an important part of the procedure, okay? The person that you're instructing, who's going to be you tomorrow, needs to be safe, okay? Make sure you talk about things like cleanup, rinsing your materials in between tests. All of those are important steps that if you don't do them, could affect your results, okay? All right, so the rest of the class is you and your group mates coming up with a procedure. All right, so you can get together with them. Unless you want to do the procedure on your own, that's fine. You cannot do the lab tomorrow on your own. You do have to be in a group, so if you need a group, let me know, okay, and we can make sure that that happens. Okay, have at it.
No.